All right, welcome back. Here we're going to talk about conversions and dimensional analysis. This is going to be using the metric ladder. How do you set it up? How do you take things down? So you got to really look at the labels. All right, so here's your metric ladder. The ones we're really going to be using are kilo, deci, centi, milli, and your base units, liters, grams, meters. All right, so your general setup for doing dimensional analysis or metric conversion or canceling units out, however people want to call it, is basically you're going to have, say, some number. Let's say you have number x with x meters. In order to cancel out those x meters, you have to times it by whatever meters it's equal to. So y is equal to, say, y is equal to y, say, in grams, which is not a possible calculation, but we'll figure it out. Notice to change this meters to grams, you have to put it on the bottom to cancel it out. So in other words, you divide by it. And then you're going to get some number in grams, so you'll get z in grams. So that's your basic setup. So remember, significant figures in this, in dimensional analysis, it's all about the least number of significant figures because you're multiplying and dividing. So here's how it works out. Let's try a couple and make sure you know what you're doing. These should all be a little bit of review. If I have a dose of 25.0 milligrams, how many grams of this medication? Well, I know that for every 1 gram I have 1,000 milligrams. So really what I'm doing is dividing by 1,000. So 25 divided by 1,000 gives me my answer. Okay, and your answer should be in how many significant figures? Well, how many significant figures does this have? 3. So it should be in 3 significant figures. All right, so get that answer, see how you guys do it. 1 serving of fruit is 0.244 liters. How many centiliters is this? Well, set it up. Liters in the bottom, centiliters on top. I know that for every 1 liter, I have 100 centiliters. Okay, why? Because it's too smaller. The liters cancels out. And your answer should be in how many sig figs? Well, how many sig figs are here? The correct answer is 3, so round this to 3 significant figures. And let's see, next one, if I have 23.5 kilometers, okay, how many millimeters is this? Well, kilometers, millimeters. For every 1 kilometer, I have 1, 2, 3, 4, 5, 6. So, geez, 10 to the 6, which is going to be 100,000 millimeters. Kilometers cancels out. My answer should be rounded to 2.3. So try some more of those. Hopefully they'll work out. Remember, they have to cancel out like that. It should be one-step cancellations, and we'll go through the rest in class. But really, this should be basic math that you guys should know how to set up. A lot of you guys could be almost just do this in your brains, I hope. All right? And then we'll go over the rest of the answers in class, but we'll do one more example here. So here we go. A telescope is designed. We're on number 4. A telescope is designed that we can see a narrow band of spectrum of light around red emissions. The solar flares. The band passes the wavelength of 0.070 nanometers. How many centimeters wide is this? Woo. So 0.070 nanometers. So I got to cancel out my nanometers. So nanometers goes on the bottom, and centimeters goes on top. All right. So for every 1 centimeter, here's 1 centimeter. Here's my nano. Difference of 7. Okay, so difference of 7. So it'd be like a million. 1, 2, 3, 4, 5, 6. Oh, that'd be 10 million. Sorry, 10 million. So 0.07 divided by 10 million. Nanometers cancels out. 2 significant figures should be in your answer because there's 2 here. All right. Well, hopefully this is a review. We'll see how you guys do, and let me know if you have any more questions.